Hey class, in today's lesson we're going to talk about trigonometric functions of any angle, which is found in section 4.4 part 2. Our objective is to evaluate trigonometric functions of real numbers. So just some steps to follow when you're evaluating trig functions of any angle. It says to find the angle of a trig function of any angle theta. First, you need to determine the function value for the associated reference angle, which is what we just did in the last lesson. Remember, the reference angle, we completely focus on the x-axis. So how many more degrees does it need to get back to the x-axis, or how many more radians does it need to get back to the x-axis? Then, depending on the quadrant in which theta lies, prefix the appropriate sign to the function value. So in other words, that all students take calculus, right? That kind of helps us remember, it helps us to remember where things are positive or where trig functions are positive. We can also use that in association with step 2. And these are just some common trig values. Over the course of time, these will they'll come out. We do them so often. We've done a video in class where, on the video, he teaches you how to kind of come up with a quick shortcut if you know quadrant 1, which then helps you to transpire to the other quadrants. You can use whatever, but this is just another resource. And again, this is another memory shortcut. Essentially, you just line up your radians 0, 30, 45, 60, 90, and then as the video stated, you would make everything a fraction, and their numerators range from 0 to 4, and then you take the square roots of them. So I also like this as a memory shortcut along with what was learned in the video. So example 5, our trig functions of non-acute angles, says to evaluate the trigonometric functions below. So we have cosine of 4 pi over 3, and we have cosecant. Sorry, it's supposed to look like CSC, just my thing doesn't allow for that. So anyways, cosine of 4 pi over 3. So first of all, you need to realize where 4 pi over 3 is. We've done this up to this point where you basically focus on the denominator, and that at least lets you know if it's in the first 2 quadrants or it's in the last 2 quadrants. Because this is a 3 in the denominator, that means it's past 3 pi over 3, which is pi. So this is actually in quadrant 3. Okay. And then since it's in quadrant 3, what we know about the ordered pairs is that we have a negative x value and we also have a negative y value. That helps us out tremendously. Past that point, you just need to know that pi over 3 with cosine. All right, if you know that it's in quadrant 3, sorry, I was trying to gather my thoughts. If it's in quadrant 3, and it's a pi over 3 means that it is a 60-degree angle. So 60 degrees is going to go as our central angle. That also means that 30 degrees is the other non-right angle. And when we were being reminded of those special right triangles, we learned that if the side that is always across from the 30-degree angle is 1, it's the smallest side, the hypotenuse is always 2, and then opposite of 60 is the square root of 3, right? Just practice writing those triangles over and over again, the 30, 60, 90 triangle and the 45, 45, 90 triangle. Okay, so if we know that, then we can go ahead and apply that cosine theta is always adjacent over hypotenuse. So for us, the adjacent side to the 60-degree angle is 1. The hypotenuse is 2. And then because this is in quadrant 3, cosine is negative. So negative 1/2 is our answer. All right, cosecant of 11 pi over 4. Well, first we need to figure out where 11 pi over 4 is. Well, it's past 4 pi over 4, which would be pi. Add another, or double that, which would be 8 pi over 4. So that means that it's not in quadrant 3 or 4. So let's continue. If it wasn't an 8, then after that, we need another 4 to get all the way back around. That would make that 12 pi. But this just said that it's 11 pi. So 11 pi is going to fall within quadrant 2. 11 pi over 4 is in quadrant 2. Okay, so since we know that it's in quadrant 2 as an ordered pair will have a negative x, but it will have a positive y. All right. Since it is a pi over 4, pi over 4s have their central angle as a 45-degree angle, which means that this is a 1 square root of 2 situation for the triangle. Now, cosecant is the reciprocal, cosecant theta is a reciprocal of sine theta. What we know about sine is that sine is opposite over hypotenuse. So therefore, we're asking for hypotenuse over opposite. Hypotenuse here is the square root of 2. The opposite is 1. And since we're talking about a reciprocal of sine, we're talking about, well, it should be positive or negative based off of the y value. And in this case, y is supposed to be positive. So square root of 2 is our answer. In our try, we want to evaluate the trig function for tangent of negative 210. First, let's start by figuring out where is negative 210. Well, negative 210, let's go negatively. This would be negative 90 degrees. This would be negative 180. So 210 must be somewhere here. Okay. We need to think about the reference angle, though, because if this was negative 180 and we're at negative 210 now, the difference between the two is 30 degrees. So let's set up our triangle based off of that information. If that's 30 degrees, opposite of 30 is 1. The hypotenuse is 2, and then this side is square root of 3. Okay, so 1, 2, and square root of 3. Okay, from there, also what we need to know is that the ordered pair in quadrant 2 has a negative x and a positive y. All right, tangent then is opposite over adjacent. My opposite side is 1. My adjacent side is the square root of 3, but let's go ahead and rationalize that because that's not going to work. So we have the square root of 3 over 3 as our answer, and then we just need to figure out if it's positive or negative. Well, remember, tangent is technically y over x, and in this case, y is positive and x is negative, so that means tangent must be negative. So we have negative square root of 3 over 3. Okay, in example 6, it says using trigonometric identities. So it says let theta be an angle in quadrant 2 such that sine theta equals 1/3. Find cosine theta by using the trig identities. Initially, I was almost going to read this incorrectly because I did not pay attention to the fact that it says by using trig identities. Okay, so let's think about that. First of all, if it's in quadrant 2, it's a triangle that sits like that. And then we also know for it to be sine is opposite over hypotenuse. So the opposite side of theta in this case is 1, which is right here, the vertical length, and then 3 is a hypotenuse, our diagonal for this triangle. Okay, but since it asks for us to find cosine theta using trig identities, we have to continue to use this using trig identities. So let's follow those steps. So that would be